Kanita.
Hi, I'm Daniel.
You know, when I think about the term electric vehicles, it sounds pretty straightforward.
Yeah, that's because the words electricity and vehicle, we use them every day. So
That's right.
they're pretty familiar.
But if you talk about how EVs are so different from the internal combustion engine vehicles, that's when it can get kind of confusing. It's a little more difficult to understand.
Yeah, you're right about that too. And that is why I am here.
And I want to first tell you about my first experience with an EV. Well, when I drove it for the first time, I don't know if you guys have experienced this, but you kind of feel this jolt. You know, it was launching you forward, and I thought it was unfamiliar because it was like riding a roller coaster. Do I put my hands up? But there was no shift in gear, so it made it even stranger.
Perfectly normal sensation to experience that sort of jolt when you're driving an EV for the very first time.
Yeah, but also when I was driving at a high speed, the energy consumption went up as well, and that also was quite surprising.
Yeah, but that also totally normal, and I can tell you why. It's because unlike the internal combustion engine vehicles, EVs, no transmission.
None.
No transmission.
Not even a small one.
There's no transmission.
All right, no transmission. I mean, how does it work then?
Good question. All right, first of all, just so we're clear, an engine and an electric motor are very different things.
All right.
Okay, a lot of people, you say engine and motor, they think same thing.
Right.
Not the same thing.
Okay.
Let me explain it. An engine converts the linear movement of the pistons into the rotary motion of the wheels. So, as you may know, explosions in the engine are going to create noise and vibration. And furthermore, fuel efficiency is an issue. So, for instance, the efficiency of the latest gasoline engine, 40% at most. For diesel engines, it's a little bit higher.
Right, so based on what you're saying, these internal combustion engine vehicles, they don't really sound that bad. It's not terrible at all, and I feel like I don't really need to choose an EV, you know?
Well, you may think so, because we've been using and developing internal combustion engines for over a century, 100 years, right? So obviously, we've accumulated a massive amount of data about them.
Right. But like you said, we've accumulated enough information and technology on these internal combustion engines. So then why do we have to switch to EVs anyway? I mean, is there a particular reason for that?
Yes. As we reviewed in the previous session, the major problems with the internal combustion engines are, 1, huge volume of emissions.
Right.
2, the lower efficiency compared to the EVs.
Okay, so what you're saying is as advanced as these internal combustion engine vehicles have come, EVs are still more efficient. Well then, let's talk a little bit more about these EVs.
Okay, unlike internal combustion engine vehicles, EVs turn the wheels with a motor, not an engine. If you look at a cross-section of the motor, there is a permanent magnet within the motor, there's a rotor in the middle, and then coils wound around the magnet. And then when electricity is supplied to the motor coils, that induces a magnetic field, and that makes the magnet rotate.
I'm just a beginner here, I'm just learning, so I think you'll need to explain it a little more in detail, a little simpler.
Okay, did you know that when electricity flows through a coil, that electric current creates a magnetic field, or it's called an electromagnet. And so a magnetic force ends up flowing around the wires. So to strengthen that force, if you want, those wires, you can wind them multiple times. That allows the coils to produce very strong magnetic forces.
How does it rotate exactly?
Good question. Vehicle motors run on a 3-phase alternating current, also known as AC. The alternating current makes a wave, and that creates a magnetic force. There's a north pole, and the other one on the end is the south pole. And if that magnetic force circulates repeatedly, a magnet inside will also rotate.
So according to what you're saying, a 3-phase alternating current is ideal for rotating the motor.
This idea was actually discovered a long time ago but we'll talk about that a little bit more later.
You know, I'm still fixed on this transmission. You know, the power generated by the motor, I feel like it should be connected to some sort of transmission.
Yeah, that's an old school way of thinking. You might think that, but it's actually not necessary. Instead, the power is transmitted through what's called a reduction gear to the wheel. Internal combustion engines, they have very weak torque when the number of engine revolutions per minute, or RPM, is low. And so a transmission is needed to move the car forward because of that weak torque.
All right, I guess so.
However, for a motor, the torque, it's strong enough to propel the car right at the beginning or at a low RPM. And that is enough to move the car right from the beginning. That's why you get that jolt. And the torque of the motor, that stays relatively consistent throughout the practical range of the RPM. That means we don't need a transmission.
So it sounds like EVs are more convenient for both drivers to drive and manufacturers to produce because they don't have that transmission.
Correct.
Well, then, so why weren't they developed earlier on? You know, used widely so much beforehand.
Actually, let's talk about that in just a little bit more detail.
Okay,
so what do you think is the most crucial part of an EV, not counting the motor?
The battery, of course.
Excellent. Now, until recently, battery tech, it just wasn't sophisticated enough. You know, there was what we call an energy density issue. That refers to how much electricity a battery can store.
Oh, okay.
Okay, here we have two different types of batteries.
I think we're all familiar with this bad boy. You know, we've seen this a bunch, so I'm pretty sure we can all figure out what this one is.
You are right. This is the 12-volt lead acid battery that typically goes into the car.
Right.
This is the 12-volt lithium-ion battery, and that goes into the latest models that are available at the moment. Now, these two batteries you see in front of you, they do the same thing, which is to power the electronics inside the vehicle. But there's a big difference. Can you guess what it is?
Oh, well, first off, I'm gonna say that. Oh my gosh! This is a lot heavier, the lead acid battery. It's bigger, it's heavier. The lithium ion battery is much smaller, much lighter, easier to handle.
Pretty big difference, right? Lithium-ion batteries are used in EVs instead of the big, heavy lead acid batteries. However, there are also significant differences in performance, okay, of the lithium-ion battery, and improvements have been made as well.
Ooh, how much?
Almost a decade ago, EVs, they could go only about 120 kilometers on a single charge. But now, they can go as far as 400 or even 500 kilometers due to the improvement of energy density in the battery.
Wow.
Yeah, not only that, higher energy density, that means that now we have the ability to mount larger batteries to extend that range of the EVs even more.
If we put more batteries, then we could even see EVs with a range of, what, 1,000 kilometers per charge?
If we put more batteries, the EVs will get heavier. That offsets the effect of having a greater battery capacity. So instead of using more batteries, EV makers will probably focus on appropriate battery capacity to enable faster charging.
Why do EVs then need batteries with a much higher voltage?
Yeah, that's a good question. Generally, the electrical devices in internal combustion engine vehicles, they operate at 12 volts for things like starting the engine or turning on the lights. EVs, they also have 12-volt batteries in order to operate various electrical devices. They also need to operate a strong motor, you know, to drive the car. So imagine, if you can, a 36 kilowatt motor. In order to operate the 36 kilowatt motor with a 12-volt battery, we'll need about 3,000 amperes.
Oh, wow.
Yeah, that's a pretty strong current. And to use that current, we'd need thicker cables to withstand that current. That cable right there is only capable of handling 16 amperes. Can you imagine how thick that cable would need to get to handle 3,000 amperes? So instead of increasing the amperes, we increase the voltage to achieve the same wattage because W equals V times A. So with higher voltage, the EVs can use lighter, meaning more efficient electrical cables. And that allows for a more efficient overall design of the vehicle. And that is also why the Ioniq 5 behind us uses an 800 volt system.
I've also heard that EVs use both DC and AC. Why is that so complicated?
Not as complicated as it sounds. DC stands for direct current, and AC stands for alternating current. This is a rechargeable battery which uses the DC. Here's the positive sign, and here's the negative sign.
Right.
Now imagine an electrical outlet on the wall.
There's no sign.
That's right.
I don't think I've seen one.
That's because the outlet you see in the wall is alternating current, or AC.
Okay. So then EVs, do they use the AC or the DC?
The high voltage battery in an EV, it uses DC to store its energy.
Oh, okay. So it only stores energy in DC then.
Correct. And that is why there are two different charging connectors. There's one for AC and one for DC. This is a portable slow charger, which uses AC, like what you get coming out of the electrical socket in the wall. And it comes, or it can come with a connector called the CCS1 DC combo. That uses DC.
Oh, okay. Yeah. I think I can see the difference now. But you did tell me that we need an AC to rotate the motor of an EV, right?
There is another part within the EV which takes care of that. It converts the DC stored in the high voltage battery into AC, which can rotate the motor.
Okay, so in conclusion, EVs can use both AC and DC. Therefore, we can essentially use either or both, just as long as we get the charging cables right.
Absolutely right. It can adapt regardless of the current type. So in the next session, we'll look at charging in just a little bit more detail. See you next time.